In this video, we're going to talk about how to handle exceptions when something goes wrong in our program. And we're going to talk about it this week for two reasons. One is that we're just getting further along in our Java development. We'd like to be able to create programs that don't just crash when something goes wrong. We'd like to be able to handle it smoothly and hopefully have the program continue. The second is that we're required to handle exceptions that might happen when we work with files. And the next video this week we'll talk about reading input from files. So we'll need this information in order to work with files. Let's look at a piece of really bad code here. And there are three problems here. There are three lines that are going to cause exceptions. Pause the video for a second and see if you can spot where are we going to run into problems here. Okay, hopefully you figured this out. First, we'll look at this line, scanner keyboard equals null. That's not technically going to cause an exception here, but it's going to not create the keyboard, so that down below, when we read in input from the keyboard, it's going to cause an exception. Keyboard is null, we'll get a null reference exception. The second place we're going to run into a problem is myArray at spot 5. The array is size 3, so spots 0, 1, and 2 are valid. Spot 5 is not valid. We're going to get an index out of bounds exception. And the last spot is this myArray1 divided by myArray0. Because myArray0 has a 0 in it, we're dividing by 0. With doubles, Java actually gets around this. We get a weird answer back called NaN, or not a number. But ints don't have a special value like that, so it throws an exception, and we'll get an arithmetic exception, and it'll have a little message, can't divide by 0. So there are three places in this code where we're going to run into problems, exceptions that we might have seen before. You may also have seen exceptions like asking keyboard.nextInt with a valid keyboard, but then the user types in something like hello, and that's going to create an exception as well. So what we're going to talk about today is how do we deal with exceptions? What do we do if an exception happens, and how do we keep our program running or respond to it? So let's look at just a simpler example here where we just have the one exception. myArray at spot 5 is that first print line. What will typically happen when this program runs is we'll just run the program like usual, and when we hit myArray at spot 5, Java will display an error message. It will say an exception happens, and it just quits the program. It stops the program running at that point. We handle exceptions using what's called a try-catch block. So you'll see try, and then in curly braces, code goes where an exception might happen. After try, there must be a catch. And in parentheses there, we'll say exception, and then we give it a variable name like EX. And then in the curly braces, code that we want to run if there's an exception. You always have to have a catch block, although you might not necessarily put any code inside of it. So you might just have catch exception EX, and then empty curly braces afterwards. After the try-catch block is the code for the rest of our program. So if an error happens in the try section, it immediately stops running and jumps to the catch. Once the catch section is done, it continues running the rest of the program. If no error happens, it runs all the code in the try section, it skips over the catch, and it continues running the rest of the program. So let's see that in action. We've got a simple program here. In our try section is this myArray at spot 5. So we run the basic part of the program. If an exception happens here, our program's just going to quit like it always has. But once we're inside the try section, an exception is going to get caught. So we try to do this myArray at spot 5. We don't run the high afterwards. There's an exception here, so we jump immediately to the catch block. In this case, I've decided to use the exception object. I'm using exception.getMessage. There's also exception.printStackTrace that will help you figure out where the exception occurred if you want to do that. But we're just displaying a little error message here, and then we'll continue running the rest of the program. Let's look at the same code, but where it's going to work correctly. So we're calling myArray at spot 2 instead of spot 5. So we run through our program like usual. We get to system.out.println myArray at spot 2. There's no exception there, so we continue. We print out hi afterwards. No exception there either. So we hit the end of our try. We're going to just skip the catch block entirely and print out myArray at spot 0, continue running the rest of the program. So let's go back to the code where we've got myArray at spot 5. We put that inside the try section because we thought there might be an error that would happen there. But exactly how big the try section is can kind of depend on what you're trying to do. We could put more code in the try section. That means if there's an error when we're setting myArray at spot 0 or 1 or 2, if there's an error there, it'll get caught. beforehand, it would have just quit the program. We can't quite do this. We can't put this myArray creation inside the try block because we want to use myArray after the try catch is done. Anytime a variable is created inside curly braces, it only exists inside those curly braces. So myArray in this example only exists inside the try block. I can't even use it in the catch, and I certainly can't use it down below after the try catch is done. So this code won't work. But if I wanted to put that print line inside the try block as well, now this new version will work. So I'm only using myArray inside the try block. Where you set up the try and catch will depend a little bit on what you want to fail if there's an exception and what you want to continue running no matter what happens. We'll talk about that and figure that out a little bit more as we work through the rest of the semester.